Hi everybody, this is Wayne Brain TV, and this is part 2 of falling asleep. And I was talking about how I was factoring all the numbers from 1 to 100 while I was falling asleep and trying to figure out which one had the most factors. And it was a three-way tie between 96, which is 5 2s and a 3, 2 times 2 times 2 times 2 times 2 times 3, right? And 72, which is 8 times 9, or 2 times 2 times 2 times 3 times 3, right? It turns out that both of those numbers have 12 factors, and it turns out that there's actually a third number, and the way you get that is by using 2s, 3s, and 5s. And let me think if I can remember here. The number that you have 2 of is the 2, I think. So you have 2 times 2 times 3 times 5. 2 times 2 is 4. Multiply the 4 times the 5, and you get 20. Multiply the 20 by the 3, and you get 60, and that is the third number. So 60 also has 12 factors. And I'm not going to try and name them all because, or maybe I should. So let's see, 2, 3, 5. So it's going to be 1, 2, 3, 4, 5, 6, 12, 15, oh, I forgot 10, and 20, and that's 10, and 30, and 60. Okay, so there you go. 12 factors. Okay. So then I started thinking, what if instead of asking how many factors a number has, I turn the whole equation around and I ask which numbers have a particular number of factors. So it turns out, if you do this, that okay, so you say, okay, I want the set of all numbers with 2 factors. And it turns out, of course, that those are all the prime numbers. And that, in fact, is the definition of a prime number. A prime number is you can only get it by multiplying 1 and the number itself. There's no other way to get the number. So there's no other way to get 5 except by multiplying 1 times 5. Right? You can divide 5 by 1, you can divide it by 5, and that's it. Those are your 2 factors. And that's it. If you have the number 6, on the other hand, you can divide the number 6 by 1, 2, 3, and 6, right? So it has 4 factors. So it has more than 2 factors. So if you say, well, which numbers have 2 factors, the answer is going to be prime numbers. If you ask which numbers have 3 factors, it's going to turn out that the answer is prime numbers squared. Okay, so 2 squared is 4, and 4 has 3 factors, 1, 2, and 4. 3 squared is 9, and 9 has 3 factors, 1, 3, and 9. 5 squared is 25, and 25 has 3 factors, 1, 5, and 25. 7 squared is 49, 1, 7, 49, 3 factors. You get the idea. And so it turns out that anytime, if you say, I want the set of numbers that have n factors, anytime n is a prime number, then the answer is the set of prime numbers raised to some power, right? So for example, if, take the number 7, for example. Okay, so I say 7 is a prime number, and I want the set of all numbers that have 7 factors. It turns out that the only numbers that have 7 factors are prime numbers raised to the 6th power. That is to say, a prime number multiplied by itself 6 times. So take the number 2, for example. If you take 2 and multiply it by itself 6 times, you get the number 64. The number 64 has 7 factors. And those factors are 1, 2, 4, 8, 16, 32, and 64. Okay? So if I pick another prime number like 17, right? The only way to get, a number that has 17 factors, remember 17 is a prime number, is by taking a prime number and multiplying it by itself 16 times. So 2 to the 16th power, which is 65,536, has 17 factors. And it turns out that all the numbers that have 17 factors are simply a power of a prime number. There's no other way to get it. It's impossible. And so I'm like, I figured this out while I'm falling asleep. And I'm like, wow, that's a pretty interesting thought. And in general, the number of ways that you can get a number with n factors is based on the factorization of n. Right? So take the number 4, for example. One way of getting numbers with 4 factors is by taking a prime number to the 3rd power. That is to say, multiply it by itself 3 times. 2 times itself 3 times is 8. The number 8 has 4 factors. Those factors are 1, 2, 4, and 8. 3 multiplied by itself 3 times is 27. And the number 27 has 4 factors, 1, 3, 9, and 27. See how that works? But it's not the only way to get 4 factors. So for example, the number 6 has 4 factors, 1, 2, 3, and 6. But you get the number 6 by multiplying 2 different prime numbers, 2 and 3. And anytime you multiply 2 different prime numbers, you get a number with 4 factors. So if you take 2 times 5, you get 10, and 10 has 4 factors, 1, 2, 4, and 10. 2 times 7 is 14. Okay, the factors of 14, 1, 2, 7, and 14, there's 4 of them. Okay, 3 times 5 is 15. The factors are 1, 3, 5, and 15, there's 4 of them. So in general, the number of factors of a number is related, or excuse me, which numbers have n factors is related to the factorization of n. So if n is 12, right, then there's all kinds of ways, because that can be, 12 is 2 times 2 times 3. There's all kinds of ways of getting numbers with 12 factors. So something for you to think about as you're falling asleep. I'm sure this will be very helpful for all you out there falling asleep. I'm done. If you like my thoughts, subscribe to my channel, and you'll get more. Bye.